Hi, we're back, 5.2b. We're using the APV formula. So here's an example. How large of a loan, it's actually a car loan, how large of a car loan can John apply for if he can only pay $300 a month? Okay, and in this car loan, the rate's going to be 12%, which is too much. Compounded continuously. Compounded here. Compounded continuously for 5 years. Okay, well, before we can use our APV, we know we have a D, and D is in years, and he can only pay $300 a month. So we have to do 300 times 12 to make it into years, and that ends up being 3,600. So APV is 3,600 divided by 0.12 times 1 minus e to the negative 0.12 times 5. Okay, and when we calculate that out, that ends up being $13,535.70. Okay, I don't know what car we can get for that price these days, and we're really lucky our interest rate is not 12% and compounded continuously. This was an old problem. All right, so we're going to another one. Let's say that we want to get a mortgage for $250,000, a 30-year mortgage. Okay, and this one's going to be 5% compounded continuously. Compounded continuously. Okay, now we're going to do an ABC for this problem. Letter A, we want to compute the monthly payment. Monthly payment. Okay, normally we'd use amortization for any kind of personal loan, car loan, house loan, but this is compounded continuously. So this is handled differently. We're going to use APV. We know that we want $250,000 is what it's going to cost. Okay. And then we have D over 0.05, 1 minus e to the negative 0.05 times 30. All right, now what we're doing is we're solving for D. Okay, put this way. All right, so I'm gonna go down because we all know how to do algebra, and my pen's running out. So D equals this 250 divided by 15.5374, and that will end up being $1,690.21 per year. But we need to know what that is per month. So the monthly, we would divide that by 12, and that equals $1,340.85. Okay, let's go on to the next part of the question. Hope my pen will last that long. All right, so we're going to letter B, and we get to use logarithms and such, combining stuff that we know that we haven't seen in a while. Okay, so let's say that we want to pay $150 more each month. Okay, the question is going to be how long to pay off the mortgage. How long to pay off the mortgage? Okay, so we have a payment of $1,340.85. We're now going to add $150 to that. So we're looking at a payment of $1,490.85. Okay, but once again, before we use our APV, we have to change this by multiplying this by 12, because D is always in years. Multiply by 12, okay? And that'll equal $17,890.20. Okay, so we're going to put 250 equals the 17,890. Divide that by 0.05, and then we're going to multiply that by 1 minus e to the negative 0.05 t. So now we're going to be solving for t. All right, taking this, dividing that by that, is going to be 0.69871. Now remember to go out on your decimals. Don't cut back at this time, because you'll get a lot of round-off error, especially with money, especially with long years. 1 minus e is negative 0.05 t. All right, so we're solving for t. This is in the way. This is negative right here, so I'm going to put on the other side and make it positive. E to the negative 0.05 t. So I made this positive by adding it to both sides. Now I'm going to bring this over here. So I have 1 minus 0.69871. And that equals 0.30129. Okay, solving for e now, we have ln of e to the negative 0.05 t equals ln of 0.30129. All right, bringing this over, negative 0.05 t, and we know ln e is 1, so we don't even have to write that. And we have ln of 0.30129. Solving for t, we're going to divide ln of 0.30129 by negative 0.05, and that is going to give us approximately 24 years. Okay, so the question was how long to pay off the mortgage? 24 years if we add $150 more. One last part to this question, and then I'll go ahead and give you your homework. Okay, so now we're on part C, and part C is how much money can be saved by paying $150 more a month. Okay, how much money can be saved by paying $150 more a month? Well, we know D for 30 was $16,090.21 per year. And D24, which we just did, ended up being $17,890.20 per year. Okay, so we're going to take this amount. What do you think we're going to do with it? That's right, we're going to multiply it by 30 years to see how much it costs total. That's $4,082,700, which is an awful lot. The house was $250,000. Banks make a lot of money on these loans. Okay, and D24 was $17,890, and that was 24 years. So that ends up being $4,029,364.8. All right, and when we subtract this, we find out the amount of money that we saved by paying $150 per month. $335.2. That is what we saved. Yay! Okay, so here's our homework for this section. Homework 5.2 is going to be 1, 3, 5, 7, 17, and 25.